Hey everyone, Oskar here, and in today's video I'm starting off something very special, which will be a new series about building TurboModules with React Native, which will be called Mastering React Native TurboModules. And in this series we will dive deep into topics like Swift TurboModules, Kotlin TurboModules, C++ TurboModules, and also the underlying foundation behind TurboModules, which is JSI, Codegen, and everything around it. So if you're interested, keep watching, and yeah, let's dive straight into the code. So TurboModules are the new build system built for the ground up for the new architecture. And thankfully, after recent announcements, new architecture is now the only architecture. So we won't cover legacy modules in this video at all. So the second thing you should know is React Native Codegen, which is a tool that crawls your project in search of TypeScript files that define how your module looks like. And it kind of defines a contract between your TypeScript files and your native code. So it takes and generates boilerplate code, like generating some C++, Java, Objective-C++, etc. We will dive in how this generated code looks like, so you know where it lives and how to read it. So first thing will be to bootstrap the library, and for this we will use React Native Builder Bob, which is pretty much the best tool if you want to bootstrap a Turbo module, Nitro view, or Nitro module, whatever, or a Fabric view also. So yeah, we'll be using React Native Builder Bob. And the goal is to keep our business logic in Swift with small glue layer in Objective-C. So you'll see how that goes. So first thing, this is the spec I was talking about. As you can see, we'll be implementing a simple local storage module, which is the example, for example, in React Native docs. So we'll have 4 methods: setItem, getItem, removeItem, and clear. And this will define the contract between our TypeScript code and the native code. So Codegen will do the magic of generating native protocols so that our implementation on the native side is type safe. And this is a huge win over the old architecture, which didn't have this end-to-end type safety between native and JavaScript. So here then we will dive into the generated code. As you can see, here is the generated header for our module. Then we will add Swift and modify the podspec file so it actually knows to link Swift. So the podspec is the file that defines how our native module will be linked. And as you can see, it defines the name, version, source files, private header files, etc. Then we will do this Swift implementation, which encapsulates all of the logic of interfacing with the user defaults API. That's a built-in API. Then we will import Swift in Objective-C and initialize the module and forward the calls. So yeah, let's jump into the implementation. So first of all, let's create a new Expo project. Let's call it Swift TM1. All right, and it finally finished. It took a second to install all the dependencies. And so as we are in our project, we will initialize a new React Native library, but as a local module. So create React Native library -- local, and let's set the name to local storage. And where do we want to store the library? It will be stored in the modules folder / local storage. That's fine. Let's do local storage implementation. And let's do turbo module. All right. Now let's do npm install. And let's examine what we have here. So inside of modules, so this is like a typical Expo app. Nothing really crazy here. But we have the modules, local storage, and here we have the Android, iOS, and the SRC, the shared JavaScript layer. So we'll be focusing on this video only on the iOS part. So yeah, here is the interface for this local storage module. As you can see, it imports local storage spec header file, which is the thing that Codegen will generate for us. And it and we conform to this protocol in here. So this is the default implementation from Bob. So by default, we get this multiply function. As you can see in the src folder, our spec by default implements the multiply function, and in here we actually do this multiplication. This getTurboModule function is what's required by TurboModules, so it knows how to initialize our module, and this is also a required method to let React Native know what's the module name. So yeah, let's start by changing the local storage spec. So let's take this and yeah, let's copy it here. So we've got the setItem, getItem, removeItem, and clear. So these are our 4 methods we will be implementing on the native side. And you might be wondering, when does the Codegen actually generate those files? Is it on save? Is it on build? And it's actually happening when you install pods. So in order to install pods in Expo, we have to first do pre-build. So this will generate the native files. As you can see, it pre-builds the project and then install CocoaPods. So now we should have the iOS folder, which we didn't have before. Now it contains our native project as it was generated by CNG by Expo. So now we will be installing CocoaPods. All right, and after this is done, we can do xed iOS, which is a shortcut of opening Xcode. So in here, let's select iPhone 17 Pro, which is the simulator on the right. And now you might wonder how to find our TurboModule. So if we go in here, there are a couple of folders. This one is corresponding to what Expo generated. You might think maybe this is here in the libraries, maybe in frameworks. Fortunately not, it's here. And there are a lot of pods defined here. So if you cannot find it, we can do search in here. And here's our local storage module. So yeah, let's collapse this and let's go in here. So as I mentioned before, this is where we will have to do a build. So Xcode actually knows and already resolved our symbols. So let's wait for a build. All right, so the build has finished, as you can see, running, but we need to do npm run start. So Metro server is started. And yeah, we've got an Expo app up and running. So now in here, this is now green, which means we can click on it. And as you can see here is the generated file. And you can see that it's generated because it has this header. This code was generated by Codegen. And here is the protocol. It's like pretty standard Objective-C notation saying what methods our class needs to implement to actually conform to this protocol. And this corresponds to our TypeScript spec. So we've got the setItem, getItem, removeItem, and clear are 4 methods that we'll be implementing. And if we go to localstorage.mm, you can see that we've got a warning that our class doesn't conform to a protocol called native local storage spec. And this is expected because we didn't yet implement all of this. So let's start to implement it. We can do getItem. For now, let's return just an empty string. setItem. We don't need to do anything here for now. removeItem. And also clear. Right, so we've got our 4 modules, 4 methods that will be then forwarding to Swift. So now let's work on the Swift implementation. So the way I do it pretty much always is to change the files not in Xcode, because when you add something in Xcode, it can be linked into a weird directory. So it's always better to work on the actual file tree. So in here, I will do local storage.swift. And this will be our Swift implementation. And inside of here, we also need to say to CocoaPods that our module now also contains Swift files. So in order for this to take effect, we need to install pods again. there's no need to regenerate the whole native project again. It's just a small change, so we can only install pods. Let's do npm run start again. And now, if we go here, you can see that now we have this local storage.swift file. So let's actually save some typing and paste the whole implementation and go through this line by line. So here we import foundation, which is standard Apple library, kind of the foundation, which contains user defaults. And in here we define a public class with the name native local storage. And we initialize a user default object with the suite name local storage, which will be kind of like a key. So other local storage, other user defaults won't overwrite our values if they use a different suite name. And in here, we just bridge the methods. So user defaults.string for key. This will be our getItem method. setItem, it's pretty much set. And removeItem is remove object. And then in here, we get the user defaults. We convert this to a dictionary. We take the keys, and for each key, we call removeItem. And the $0 is just a way of referencing the first argument passed into a closure in Swift. So I hope this is pretty straightforward, but this Objective-C members, this is where the magic of Objective-C happens. So thanks to this, every method and this whole class is now able to be called from Objective-C. But one thing you have to keep in mind is that, for example, we cannot use every Swift type. So if you use a struct or something that's not directly available in Objective-C, it wouldn't work. So we will have to use things like string and types that have a direct representation in Objective-C. So that's something to keep in mind. So now that we have this whole implementation in Swift, let's go back to local storage. And how do we actually run it here? So first of all, we need to have import the Swift header file. So this is generated by the system. So if our module defines this at Objective-C and it has Swift, it will be actually generating this file. So our pod name -swift.h. And in here, as you can see, this interface is now visible so that Objective-C can call to our class and all of the methods are visible. So if at any point you face some issues with calling from Objective-C to Swift, you should check this file to see if it's actually being generated. If not, then you are probably missing this at Objective-C members. And this big if is for dynamic frameworks. So if your app is enabling dynamic frameworks, so inside of the pod spec, it would be use frameworks dynamic, then each module has a prefix for the imports. So in here, we just check if we have include our name / this import, then we use this import. And if it doesn't, if we cannot find this header, we'll use just a normal import, which means we don't have dynamic headers or static headers, dynamic frameworks or static frameworks enabled. So yeah, now let's store the module implementation that will be tied to the lifetime of this object. So we will do native local storage _ local storage. So this will create an Objective-C Ivor, which is just an instance variable that will be tied to the lifetime of this local storage module class. So in here we override the init, and inside of init we can actually initialize the object. So alloc init is the way you initialize objects in Objective-C. So we pretty much store it here. Inside of the init method, we initialize this object, and we need to initialize this because we actually reference a variable on here. So if your module doesn't require to store anything, you could actually do all of those methods could be static public functions, and you just bridge to a static method. But in here we initialize the user defaults, so we need to actually first store this native local storage implementation, and then on each method, we can actually call, so local storage getItem for key, and we need to return underscore local storage setItem for and key value, local storage remove, and clear. All right. So now each of those Objective-C methods bridges to a corresponding call to Swift. So let's place some breakpoints once we will be running this. So these breakpoints are now great because this file is not yet compiled. So let's compile it. And one more thing we will need to change on the module side is in here, in this index.tsx, we still reference this multiply function. Let's just write export let's just export default everything from this native local storage. So now in an index file, we can import local storage from native local storage. And let's copy paste the test code for the index file. All right, so I've got the test code. So in here, we call local storage.setItem with the value hello Expo and the key greeting. And we use this under one pressable. We call this under one pressable. And then in another function call, we retrieve the getItem for key greeting and alert. So this first button will store the value. And as you can see, now the breakpoint is called and we can examine if the key is correct. Yes, key is greeting. Value is hello Expo. So this is correct. And now we press to retrieve. So in here, we try to retrieve for the key greeting, which is also correct. Let's see if this works. And indeed, we've got the alert with the value we saved into local storage. And this will be also persisted in between reloads as this is saved to the local storage of the device. So yeah, that's pretty much it. I wanted to keep this example simple so you can expand on the complexity of your modules on your own. But yeah, this should give you a nice overview of how to write TurboModules with Swift. Thank you for watching this video. If you want to go deeper in the topic, make sure to check out other videos from this series. And if you enjoyed this video, make sure to give it a like, drop your questions in the comments, and also make sure to subscribe to Callstack channel so you don't miss next episodes. See you.